Hi again, Lloyd Reber here with the next presentation in the course Research Methods in Instructional Technology. The topic of this presentation is planning your research project. Here are the objectives of this presentation. First, you should be able to explain the basic research process that is common across all types of research and is common across almost all academic disciplines. Second, you should be able to describe the nature and role of the data in research and strategies to enhance validity and reliability of the measurement instruments. Third, you should be able to distinguish characteristics between quantitative and qualitative approaches to research. And finally, you should be able to describe ethical issues in conducting research, especially research involving human subjects. The whole point of this chapter is to advocate an organized, planned approach for conducting a research study. The authors use the analogy of architects developing a set of plans before the construction of a building. Just like those architects, researchers need to be as detailed and as precise in the design of their research project, just like the design of a building. So we can define the term research design as a general strategy for solving a research problem. The research design involves all of the planning to include the procedures to follow during the study, what data are going to be collected, and what data analyses are going to be used in order to make sense out of the data. The more prepared and more organized you are, in other words, the better your plan is, the more efficient and effective your research study will be. All research follows a basic format. The general research procedure is fundamentally the same no matter which academic discipline we are doing research in. And it's often true that the boundaries of the discipline for a researcher often become blurred. Certainly in educational research, we deal with issues that are going to involve sociology, psychology, policy, such as in schools or in corporate settings, and even economic issues as well. The illustration you see in front of you presents the basic format for the research process. As the book points out, this is the general sequence, but it is not necessarily always exactly the same sequence for every single study. As we will see later in this presentation, there are some fundamental differences philosophically and otherwise between some of the major paradigms of research, best summarized as the difference between quantitative and qualitative research. Let's go over these steps very briefly. Step 1, a question is posed. This question comes out of the mind of the researcher who has a question about something that there is no known resolution. Step 2, it's a matter of words. As we've encountered in previous chapters and recordings, we need to convert the question into a clearly stated research problem. Step 3, it's worth a guess. Here the researcher poses a hypothesis or series of hypotheses. Step 4, the search is on. The researcher begins looking for literature, for ideas that will shed light on the problem, or for strategies that are going to help the researcher address the problem. Step 5, data, hard data, and nothing but the data. It is only through the collection of data that address the problem can the researcher actually begin to understand what the problem is and to perhaps come up with some solutions or resolutions for the problem. Step 6, how do the data fit together? After collecting the data, the researcher must organize it into some logical structure. Step 7, the data speak. Here the researcher analyzes and interprets the data to determine the meaning. Finally, step 8, it's either or, and this means we are going to determine whether or not the data we've collected are either going to support the hypothesis or they do not. Remembering that the research plan is the same as the research design, it's important not to confuse the research plan with the research methodology. Whereas the research planning may be similar across disciplines, as we've just described, the actual research methods a researcher might use to collect and analyze data will indeed be very specific to a particular academic discipline. And every researcher needs to be considering issues of practicality and feasibility. As you come up with your research plan, you have to be honest with yourself to understand whether or not you have the wherewithal, the resources, the time, and access in order to actually carry off the research plan. And if the research plan that you have come up with is not practical or is not feasible, it's really in your best interest to go back and redesign that plan so that it is. All research is ultimately tested by certain criteria that must be built into the research design in the planning stage. Let's briefly consider the general criteria for a research project. The first is universality. This simply means that any competent researcher should be able to carry out the research plan. We should be suspicious of any researcher who claims that only he or she is able to do the research and the results that are found could only be found if that one single person was the person who carried out the research. As we will see later, there is an exception to this criterion when we consider the nature of collecting qualitative research. The second criterion is replication. And this is very similar to the criterion of universality. It means that the research should be repeatable. So, for example, consider another researcher who reads the research report, finds it very interesting, and decides, I'm interested in this topic, I'd like to do some research in it also. If they were to start with taking the research design as it was previously carried out, and if they were to follow that research design very carefully, they should get very similar results to the original researcher. The third criterion is control. Control is a very important issue, mainly in experimental research designs. Here we're trying to make sure that all of the factors are exactly the same except those for which we are actually investigating. This criterion is much more easily met in the physical sciences than in the social sciences. Consider, for example, a research study that is comparing two different types of reading interventions. If the research was carried out in a variety of classrooms involving a variety of teachers, it would be important that the assistance that each of the teachers give the students while they're going through the reading intervention program is exactly the same. Of course, we know how difficult this would be to actually control. As we will discuss later, many would argue that trying to put control over a social science situation like we have in educational research would make the research itself quite artificial. But it all depends on the research design and the research methodology that is being used. The last criterion is measurement. Here, the issue is how are we going to measure the variables that we have identified in our research design. Again, this is more easily accomplished in the physical sciences than in the social sciences. In educational research, we're often very interested in trying to measure learning. But doing so clearly and precisely can be a very elusive adventure. So let's consider the nature and role of the data in research. It's important to note that data are not absolute reality, but manifestations of the reality. So, for example, we might be very interested in knowing what somebody has learned about a certain content area, but how do we gain access to the answer to the question, what have they learned? We can't look inside their heads in order to find out what they have learned. Instead, we have to ask them to do something, to perform something. Perhaps to take a test or to answer some questions that I have for them. The better my instruments and my procedures, the closer I can get to the truth. But we have to realize we will never actually reach the ultimate truth when we do research. We also need to remember that data are transient and ever-changing. What somebody knows about a particular subject isn't static. It changes over time. Much educational research also asks for the opinions or introspections of people. And obviously these can change very widely over time, even within the course of a few hours. Anyone who's ever answered an opinion poll about political candidates knows this firsthand. You may have one opinion one day and a very different opinion the next. One of the most important concepts that a researcher needs to know is the difference between primary data and secondary data. I think the one example in the book explains this very well, where you imagine yourself a witness to a car veering off the road. The interview that you give to a police officer or your sworn testimony in a courtroom about the accident would be a good example of primary data. But a reporter who is covering the story and writes up a report of the accident in the newspaper would be an example of secondary data. That is, the reporter uses the primary data, such as the testimony in the courtroom, as a way to write their newspaper article. So if a relative of yours reads about the accident in a newspaper, what they are reading is an example of secondary data, the newspaper reporter's article about the accident. The difference here cannot be overemphasized. When you are doing your reviews of literature, you want to focus your attention on articles that report primary data. Here you see reported the actual data collected by the researchers and their interpretation of that data. The review of literature that you write would be a good example of secondary data. That is, no matter how good your review of research is, if somebody were to read your review of research, they are getting a second-hand account of that primary data. So, primary data are the most valid and the most illuminating because they come much closer to the truth than secondary data. With all of the attention and importance that we're placing on the data, I'm sure you can understand how important it is to identify appropriate measurement instruments. The decisions we make on how we're going to measure something is going to be the basis upon which the entire research effort rests. Frankly, I think those of us who do educational research have a much more difficult time than people say in physics or chemistry. Sometimes I wish all I had to do was measure the heat output of something. At least there I know I could just use a thermometer to measure that. Measuring such things as learning, motivation, or opinions are never going to be that precise. Now, that doesn't give me an excuse to do any kind of sloppy research. It just creates a greater challenge and burden on the part of the educational researcher. As people read our research reports, or as we read the research reports of others, we need to know exactly, in explicit, concrete terms, what instruments were used and how the information was gathered. And there needs to be evidence that the instruments do have a reasonable degree of validity and reliability for the purposes of the research itself. Now, you might recall from an earlier presentation that we talked about validity. Recall that the validity of a measurement instrument is simply the extent to which that instrument measures what it is actually intended to measure. And researchers typically talk about 4 different types of validity. Of these, the first, face validity, is probably the least robust. As the name suggests, face validity is simply the extent to which on the surface some instrument appears to be measuring a particular characteristic appropriately. Content validity is very important to the educational researcher. Here, the goal is to come up with a measurement instrument that is going to measure as precisely as possible someone's knowledge of or performance in some content area or domain. A lot of educational research takes place in the schools, so we want to know how much students have learned in the typical content areas of, say, math and science. In business and industry, we might be interested to know what an employee knows about the current tax laws. So the instrument we design to measure their understanding or knowledge of the tax laws would need to have a high content validity of the tax laws themselves. Criterion validity is the extent to which the results of an assessment instrument correlate with another related measure. The book gives the example of giving someone a personality test to try to assess how shy or outgoing they are. Now, there are lots of personality tests like that available, so a researcher who comes up with one that maybe takes half as long to administer than a commercial one would be very interested if their instrument has the same relationship to this personality trait as another instrument that has a proven track record. Construct validity is also very common in educational research. Construct validity is the extent to which an instrument measures a characteristic that cannot be directly observed, but instead must be inferred in patterns from people's behaviors. A really good example is motivation. Think about it. How can you measure someone's motivation for doing something? Yes, you can just ask them if they are motivated, but we all know that there is probably very little validity in doing so. That is, they may say one thing, but really believe another. As a little sidebar, there's some really interesting research dealing with what's called continuing motivation. And here, the researchers have used the idea of what people are wanting to do when all external pressure to do so has been removed. That is, if the participants really feel that they can do whatever they want, then one would probably trust more so that whatever they choose to do next is a good example of their true motivation. The book lists many other examples of constructs that cannot be measured directly, such as creativity, racial bias, and so I hope you get the idea of what we mean by a construct. And recall from our previous discussions the importance of determining the reliability of measurement instruments. You might recall that reliability is the extent to which a measurement instrument yields consistent results when the characteristic being measured has not changed. So imagine being a student in a chemistry course and you have studied very hard for an upcoming test. If the test has high reliability, you should get almost exactly the same score if you were to retake the test immediately. If your second score is much different from the first score, you would say that the reliability of the test is very low because obviously your knowledge of that chemistry content has not changed. And the book talked about a variety of ways that we actually measure reliability of our measurement instruments. Here are some examples. Inter-rater reliability is the extent to which two or more individuals evaluating the same thing give identical judgments. Internal consistency reliability is the extent to which all the items within a single instrument yield similar results. So if I give an employee a test of the new tax laws and there are 5 questions about a certain tax law, that employee should get the same score on all 5 questions. Equivalent formed reliability is the extent to which 2 different versions of the same instrument yield similar results. This form of reliability is often very important in the use of standardized testing. And finally, test-retest reliability is very similar to the example of the chemistry test that I just talked about. Given the assumption that the person's knowledge of that content has not changed, they should get a similar score every single time they would take the test. The book also talks about other ways to enhance the reliability of measurement instruments. They talk about the need for standardization, in that we should be giving the instrument in exactly the same way from one person to the next. And there are other threats to reliability that the book did not mention that I think are very important. For example, if you're giving someone a written test or a survey, the way you write the questions can have a very big impact on reliability. For example, if I ask a question in a very ambiguous way, I may interpret the question one way if I answer it one time, or I may interpret it another way if I were to answer it again. So, good writing, good clear writing on an instrument like that would be a way to improve the reliability. Now let's consider linking data and research methodology. The book used the analogy of mining and compared data to iron ore. The data contain pieces of truth, but they are in a very unrefined state. So to extract meaning from the data, we need to use what is called research methodology, similar to what a metallurgist would have to do in order to extract the iron from the ore itself. So in this way, data and methodology are interdependent. And to a large extent, the data themselves dictate the research methods. If I want to understand bullying on a playground, I cannot understand that with a laboratory experiment. I would have to be on the playground itself and observe the behavior of children. Other data may call for interviewing techniques. And yet other data may require a very close comparison between two forms of some intervention. And there, maybe a laboratory experiment would be in order. In educational research, we really do need to be open to a wide range of methodologies. The range of research methodologies can be summed up well with the two terms quantitative and qualitative. And both have a long-honored history in educational research. As the term suggests, quantitative involves quantities. Therefore, measurement is made with numbers. So we might reduce somebody's understanding of a particular area with their score on a test of that topic. Qualitative measurements, on the other hand, tend to involve words. Here we are summing up our measurement with a description, a narrative of some sort. Also, quantitative research tries to answer questions typically with the purpose of explaining, predicting, and controlling phenomena. Whereas qualitative research tries to answer questions about the complex nature of phenomena, often with the purpose of describing and understanding the phenomena from the participant's point of view. And as you will gather from reading the textbook, there are definitely different philosophical points of view associated with each of these two research methodologies. For example, quantitative research is often aligned with positivist philosophies. That is, a belief that there is a world or universe out there, and our job as researchers is to discover it. In contrast, qualitative researchers tend to take a more interpretive or constructivist approach, in that there is not the view that there is one reality out there, but instead multiple realities, and we're trying to understand that, again, from the point of view of the participants. But we are speaking in broad generalizations here. So you should not feel that if somebody uses numbers that they are not necessarily a constructivist, and if they are using words they are not necessarily a positivist. But these are some of the issues, philosophical and otherwise, that you will often see represented in the literature. I thought the book did a very nice job of presenting the comparison between quantitative and qualitative in Table 5.1. And here on the next two slides, we've duplicated that table for you. So to cover some of the highlights, we might say that the purpose of quantitative is to explain, predict, confirm, validate, or to test theory, whereas qualitative, the purpose is to describe, explain, explore, interpret, and to build theory. For quantitative, the nature of the research process is very focused and is exploring known variables, whereas in qualitative is much more holistic and the variables are often unknown. A quantitative approach often uses predetermined methods, whereas a qualitative approach, the methods would emerge from the research itself. Many quantitative researchers try to have an experiment or research that is somewhat context-free, whereas qualitative researchers feel that research must be context-bound. As we've already said, data collection from a quantitative view involves numerical data, whereas qualitative data tends to be more text-based. Quantitative data tends to have very large samples, whereas qualitative research tends to have very small numbers of people participating. Analyzing quantitative data usually relies on statistics, whereas in qualitative research, the researcher is looking for themes and categories in the narratives that have been collected. Quantitative research stresses objectivity, whereas qualitative researchers acknowledge that the analysis is often very subjective and potentially biased. And for this reason, qualitative researchers are often very careful to reveal what their own biases are, so that they are more aware of their biases, and also the readers of the research are aware of those biases. Quantitative researchers rely more on deductive reasoning, whereas qualitative researchers rely more on inductive reasoning. That is, quantitative researchers will be starting with premises and then drawing conclusions from them. In contrast, qualitative researchers will make very specific observations and then try to draw inferences about larger and more general phenomena. But again, remember, we are making very broad generalizations here, and quantitative researchers and qualitative researchers are not exclusively one or the other, as you might see here. And indeed, I think there's a lot of value to having what is called mixed methods approaches, where you use the best of both quantitative and qualitative approaches. Now, although we have talked about the validity of measurement instruments, it's also important to consider the validity of your research method. Researchers will talk about internal validity and external validity. And there's a very interesting dynamic between these two. They, in a sense, compete with one another. Oftentimes, the more internal validity I have or want, it will then reduce the amount of external validity, and vice versa. And really, internal validity is the extent to which extraneous variables have been controlled by the researcher. So remember the example I gave earlier about trying to compare two reading interventions. If we were really concerned about the differences between different teachers who were involved in the research, I should remove those teachers from the research, and instead the researcher should be the teacher for all of those different classrooms while the research was being conducted. This would ensure that whatever assistance was required by the teacher during the research would be very consistent from class to class. And there have been some very well documented examples of threats to internal validity over the years. One is called simply the Hawthorne effect. This gets its name from a factory that was called the Hawthorne Works, located outside of Chicago in the late 1920s. The research was looking at employee productivity. And they were doing all kinds of interesting things, like the effect of, I think, music, or the effect of different lighting on worker productivity. And the interesting thing was that it seems like that no matter what the researchers did, worker productivity went up. Simply put, the workers liked the attention that they were getting, and they were just trying very hard to do a better job for the sake of the research. Now, obviously, this effect is not attributable to whatever the experiment was, increasing the lighting or so forth. It was something very temporary and would go away after the researchers left the scene. And the book talks about other ways to ensure internal validity in a research study, such as a very well-controlled laboratory study, a double-blind experiment, unobtrusive measures, and triangulation. External validity is the extent to which the results that were found in the research apply to situations beyond the study itself. That is, do the results generalize to other contexts? So, an obvious criticism of the study comparing the two reading interventions where the researcher plays the teacher is that that's not how it is in real life. The different ways that teachers may assist students as they're going through the reading intervention program are going to be varied. And the research intervention is going to be used in a practical place like a school. So if the research shows results done in a laboratory, maybe the external validity is so low that we really can't count on that intervention being useful in a school environment. So again, both internal and external validity are important, and the two have to be balanced appropriately. You can never maximize each. Instead, you're looking for each to be optimized. You might give up some internal validity in order to get some very important external validity, and again, vice versa. Now, qualitative researchers think about validity in very different terms. Indeed, they really don't like the term validity at all, and instead prefer terms such as credibility, dependability, confirmability, verification, and transferability. Indeed, many qualitative researchers believe that the whole idea of replication of the research or generalizability of the research is not an issue they need to attend to really at all. Instead, a qualitative researcher will leave it up to the reader to determine whether or not their research is going to generalize to their, meaning the reader's, context. Another technique that qualitative researchers use is triangulation to help to determine validity, and that is comparing multiple data sources in search of common themes to support the findings. And this is really an analogy coming from navigation. If you can think about navigation, where you have different radio towers trying to tell you where your position is, if all of the information gathered from those towers tell you you are right here with these coordinates, then you can trust that data. Well, in a similar way with qualitative researchers, if you get different points of view that all point to the same pattern or the same interpretation, then you have more confidence in that interpretation. And qualitative researchers really rely on strategies such as extensive time in the field gathering data, having a very thick description based on narrative and the words of the participants themselves, feedback from others looking at the interpretation that the researcher is coming up with to see if it is aligned with what the data show, and also to ask the respondents themselves, the people who participated in the research, to validate or confirm that what the researcher is interpreting is in fact aligned with what the participant meant. Almost without exception, educational research involves studying people. Therefore, there are many ethical issues that we need to consider when doing our research. We need to protect people who participate in our research from any kind of harm, physical or psychological. One of the hallmarks of research involving human beings is the idea of informed consent. That is, any person who is participating should be informed exactly to the nature of the study to be conducted, and their participation must be voluntary. Now, you might think this should all go without saying, but unfortunately there's a long history of very unethical forms of research, and probably the most brazen were the research carried out on human participants by Nazi Germany. So in the last 60 years or so, we have had some very strict guidelines, and there are internal review boards, often called institutional review boards, set up by institutions. University of Georgia has one that will review any research plan that would involve human subjects, and to make sure that the research that is going to be carried out would adhere to all ethical guidelines. If you were to do any research as a representative of the University of Georgia, you would have to get approval before collecting 1 iota of data. So you've identified the research design and the methodology. You've considered issues related to validity and reliability, and you've addressed ethical implications of the project. Now it's time to make some hard decisions about how to acquire and interpret the data you're going to need for resolving the overall research problem. The first question is, what data are needed? So will you need test scores? Will you need standardized test scores? Will you need classroom observations? Will you need workplace observations? Will you need interviews? Will you need survey responses? You really need to think about what kind of data are going to be needed. The second question is, where are the data located? If you have a research study that wants to look at the relationships between some kind of intervention and standardized test scores that are being given in a local school district, you may find out that you do not have any authority to go to that school district to get access to those standardized test scores. You might be very interested in the histories and backgrounds of Fortune 500 executives, but you may be dismayed to find out that they don't want to talk to you. So the third question is, how will the data be secured? Just being able to find the names and addresses and maybe telephone numbers of Fortune 500 executives would be a difficult task. And the final question, and maybe the most important question of all, is how will the data be interpreted? So you've overcome the other three questions, and now you have data in hand. You need to describe precisely what you intend to do with that data in order to solve the problem or to answer the question. And the chapter ends with a nice set of guidelines for helping to decide whether to use a quantitative or qualitative approach. They suggest considering your own comfort with the assumptions of the qualitative tradition. Consider the audience for your study. Consider the nature of the research question. Consider the extensiveness of the related literature. And consider the depth of what you wish to discover. Consider the amount of time you have available for conducting the study, knowing that a qualitative research study often will take much more time in the field. Consider the extent to which you are willing to interact with the people in your study. For example, a qualitative researcher really needs to be an expert interviewer. Do you have those skills? Are you comfortable talking to people and probing their understanding or their backgrounds or experiences? Can you go with that flow of that questioning? Consider the extent to which you feel comfortable working without much structure, because a qualitative researcher needs to be comfortable with less structure, whereas a quantitative researcher would design structure into the experience before starting to collect the data. You need to consider your ability to organize and draw inferences from a large body of information. As we said earlier, qualitative researchers tend to focus on inductive patterns of logic. And you need to consider your writing skills as well. A qualitative research study demands very good writing skills, even though I would also say a quantitative study does as well. But since you are relying in a qualitative study on writing and interpretation that is based on narrative data anyhow, writing is of paramount importance. Finally, an excellent suggestion is to conduct a brief pilot study as a way to determine the feasibility of your research plan. Indeed, you cannot anticipate everything in advance. And the best way to learn about whether or not your plan is a good one is to start doing some research on a smaller scale. If you are going to be doing interviews, doing a pilot study in order to get some experience in conducting interviews is a very good suggestion. And pilot studies give you a sense to learn more about yourself and to know what methodologies are more consistent with your own skills and strengths. So, in closing, research design is really the planning for the research. We need to remember that data are manifestations of the reality. They are transient and ever-changing. Quantitative and qualitative approaches are different in their purpose, process, data collection, data analysis, and how they report findings of the research study. The validity of your method should be considered no matter what research methodology you choose. And of course, when you are involving human subjects in your research, ethical issues must be seriously dealt with, and the rights of the participants must be protected.